Hey guys, welcome back to my channel and this is Varun Tahin. So we have seen that hypothesis testing plays a crucial role in identifying the correctness of our assumption. And we have also seen in our previous sessions how we can build hypothesis around any problem and evaluate the critical values from the problem statement. Now ultimately we have to make a decision using the lower and upper critical values depending upon whether it is a two-tailed test or a one-tailed test. So today we will try and see important method known as critical value method to help us make informed decisions based on the statistical values. Now what we will do is we will take the AC sales example from the previous session and we'll see how critical value method helps us in taking informed decision here. Okay, so let's say that the null hypothesis here says that the population mean is 350 sales per store, and the alternate hypothesis becomes the population mean is not equals to 350. Now if the sample mean, okay, that is x bar, is also 350, then we can say that there is no change in the status quo. And if the sample mean is not equals to 350, then there is a change. Okay, so there can be two cases here. If the sample mean very far from 350, then we reject the null hypothesis and accept alternate hypothesis. But if sample mean is very close to 350, then we cannot reject the null hypothesis. Now we will follow critical value method by solving one problem. Okay, so let's say that mu is 350 and standard deviation is 90 and the sample mean is 370.16 and the number of samples is 36. Okay, so the first thing we will do here is we need to calculate the standard error. Okay, so sigma for the sample is standard error, which is sigma by square root n. Okay, so we will place the values here. So 90 by square root of 36, which is 90 by 6 equals to 15. Now next what we need to do is we need to calculate the critical value. Okay, so this is missing and there is something called as probability of error, which is also denoted by alpha or is also known as significance level. So let's regard this as 0.05. So what this signifies is that 5% of the cases will reject null hypothesis if it is actually true. Okay, in other words, 95% of the cases will fail to reject when it is actually true. So this is called as probability of error because this is the error percentage that we are considering. And then there is another fresh term which is ZC, which is also called as Z critical, which signifies the Z score for boundary points of critical region. So let's understand this with the help of graph. Okay, so I'll just draw this graph over here and let's mark Z critical over here. Okay, so I'll just use different color. Let's say that this is ZC and here this is ZC. Okay, now when I say 0.05, it marks the cumulative probability of this region. So let's say that this is A and this is B. So A plus B will be 0.05. In other words, A plus B signifies LCV and UCV. Okay, so here you can say that this is LCV and this is UCV. Okay, so this becomes 0.05 and it is equally distributed, so each of them becomes 0.025. okay, so this region also is 0.025 and this is also 0.025, which is exactly half of this, correct? LCV equals to UCV equals to 0.05 divided by 2, which is 0.025. okay, now if this region and this region is 0.05, then what is this region? This will become 1 minus 0.05, which is 0.95, correct? So let me mark this as red. Now what if we want to find the normal cumulative probability of this point ZC? We will subtract 0.025 from 1, right? So this will become 1 minus 0.025, which is 0.975, which is the cumulative probability till this point. So let us just recap the steps what we have done till now. So first we have defined a new quantity called as alpha, which is also known as significance level for the test. and it refers to the proportion of the sample mean lying in the critical region. So for this test, we have taken this alpha as 0.05 or 5%, and then we calculated the cumulative probability of the upper critical value or UCV from the value of alpha, which is further used to find the Z critical for the UCV. Now, basis on our understanding of the previous example, can you pause the video and solve these questions for me? So the first question says that we have to find the area of critical region on the right hand side of the distribution if alpha or the significance level is 3%, and this is a two-tailed test. Okay, so as we can recall that we have to distribute this among the left hand side and the right hand side because this is a two-tailed test. So each of the region will have 0.015 as the area, correct? So the UCV here becomes 0.015. And what about this? So the question is same, but it is asking for the upper tail test. So since upper tail test will be concentrated on the right hand side of the distribution, so whole 3% will be on the right hand side. Okay, so it will be 0.03. And what about this value of the cumulative probability of UCV if alpha is 3%, and we are talking of upper tail test, right? So let's say that this is the region and this represents 1 as the probability. We all know that the sum of all the probability is 1. So the cumulative probability from the beginning to the end is 1. And if it is an upper tail test, you will have something here, right? So the ZC will be here and you have UCV as 3%. So this will become 0.03. Now what will be the cumulative probability till this point? It will be 1 minus 0.03, which is 0.97. So now we will continue our example with the critical value method. So what we have done is we have found the alpha and we have segregated into 0.025 in both of the regions, and then we have found the cumulative probability till the upper critical value, okay, which will be 1 minus 0.025. So this will give you this region. Now the next thing what we need to do is we need to find the critical value, okay. So critical value will have a formula of mu plus Z critical into standard error, okay, which is represented by this. Now in order to put values into this, we need to find the Z critical value, right? So we will find out Z critical for LCV and for UCV both, okay. So for UCV, Z critical will be the value of Z from the Z table where the cumulative probability is 0.975, okay, which we have calculated here, okay, because the cumulative probability till this region is 0.975, and for LCV it will be the value of Z where the cumulative probability is 0.025, because till this point the cumulative probability is 0.025. Now in order to find the values from Z table, we will go to the Z table and we'll navigate to 0.025 in case of LCV, okay. So we will find 0.025, which is this one, okay. So it is minus 1.96. So here we will mention minus 1.96, and for the other one we'll go to the positive table and check where the cumulative probability is 0.975, okay. So ideally it should be in 1.96, okay. So you can find this, it is 0.975, okay. It is 1.96 from the Z table, okay. So we'll note here 1.96 positive. So these regions are minus 1.96 and plus 1.96. Now what we will do is we will substitute the value in the critical value and calculate the LCV and UCV, okay, which are actual values, okay. So for LCV it will be mu, that is 350, plus value of Z critical, which is in this case minus 1.96, and then into standard error. So standard error we have calculated previously also, guys, which is sigma upon square root n. So sigma is 90, square root n is square root 36, so it comes as 15. So this when you calculate, it will come to 320.6. And the same way for UCV, it will be 350 plus 1.96 in this case into 15, and this will be 379.4. So any value which is less than 320.6 or greater than 379.4 will fall in the critical region, which is this region. Correct. Now, as we can see that the sample mean is 370.16 and 370.16 lies between 320.6 and 379.4, which are the LCV and the UCV. Okay, so identically saying that it is inside this acceptance region, correct, or non-rejection region. Therefore, we cannot reject the null hypothesis, which is H naught. Now let's recap on how do we make a decision using the critical value method. Okay, so first we calculate the value of ZC from the given value of alpha, that is significance level, and take 5% if not specified in the problem. Okay, now second step would be calculate the critical values, that is UCV and LCV, from the value of ZC, which is Z critical, and then finally make the decision on the basis of the value of the sample mean with respect to the critical values, that is UCV and LCV. Now this will be all for today, guys. This is a quick session to introduce you all to critical value method. I hope this video helps you to understand the underlying significance of hypothesis testing with respect to decision making process. I will be covering more scenarios on critical value method in the upcoming sessions, so please tune into my channel and don't forget to subscribe and like my content. Thanks for the love and support you are giving me. I am really grateful to have you as my audience. Keep learning and keep rocking. I will see you soon in the next session. Until then, thanks and take care.